Gravitation Part 5 Thrust and Pressure. In the previous video, we learned about mass and weight. In this video, we will learn about thrust and pressure. Imagine you are standing in a desert and your feet go deep into the sand. Now lie down on the sand and you will notice that your whole body does not go that deep into the sand. In both situations, the force exerted on the sand is your body weight. We have learned that weight is the force which acts vertically downwards. Therefore, here the force is acting perpendicular to the surface area of the sand. This force acting perpendicular to the surface area of an object is called thrust. SI unit of thrust is the same as that of force, that is Newton. But why did you start sinking in the sand while you were standing and not while you were lying down on it? To understand it better, let's look at another situation. Have you ever fixed a poster on a bulletin board with the help of drawing pins? You will have to apply force on the head of the drawing pin. The force on the drawing pin is perpendicular to the surface area of the bulletin board. This force acts on a smaller area on the tip of the drawing pin. Now let's understand how the concept of thrust is related to pressure. Let's go to the desert example again. When you are standing and lying on the desert sand. When you are standing on the sand, the force is acting on an area equal to the area of your feet. Whereas when you are lying on the sand, the force is acting on an area equal to the area of your body. The contact area is larger in the second case. Therefore, the effects of force of the same magnitude acting on different areas are different. Thrust is the same in both cases, but its effects are different. Thus, we can conclude that the effect of thrust relies on the area on which it acts. The effect of thrust is more when the area upon which it is acting is less. Thrust per unit area is called pressure. Pressure is equal to thrust upon area. Substituting the units of thrust and area in the previous equations, SI unit of pressure is Newton per meter square. To honor the scientist Blaise Pascal, the SI unit of pressure is termed as Pascal. It is denoted as PA. Now, let's understand how pressure acts on the fluids. Like solids, fluids also have weight. They exert pressure on the base and on the side walls of the container in which they are enclosed. Let us now see how this relates to our next topic of buoyancy. Why does a huge ship made from iron and steel float on water, while a small needle sinks in the water? Now, let us perform an activity to understand the role of buoyancy in these two instances. Take an empty plastic bottle with a closed lid and try to immerse it in a bucket of water. You will see that the bottle floats on the water surface. Try to push the bottle deep into the water, and you will experience the presence of an upward force. push the bottle further till the bottom of the bucket and release it. You will notice that the bottle bounces back and floats on the water. Is gravitational force not acting on the bottle? Why does it keep bouncing back to the surface? Gravitational force is acting on the bottle in the downward direction, and the water exerts an upward force on the bottle. As a result, the bottle keeps floating. Therefore, we can conclude that the upward force of water is more than the gravitational force acting on the bottle. We have learned that the weight of an object is the gravitational force acting on the object. Thus, we can say the upward force exerted by the water on the bottle is more than its weight. This upward force is called buoyant force or upthrust, and this property is known as buoyancy. Now, let's do another activity to find out why a substance floats or sinks when placed on the water surface. Take a glass filled with water. Place a nail and a cork of equal mass on the surface of the water. You will notice that the nail sinks while the cork floats on the water. It is because of the difference in the densities of the substances. Density is defined as the mass per unit volume. Its unit is kilogram per meter cube. The cork floats as its density is less than that of water. It means the upthrust on cork is greater than the weight of the cork. While the nail sinks as its density is more than that of water. It means the upthrust on the nail is lesser than the weight of the nail. Have you heard about the Dead Sea? The water in that lake has the highest salt content, and so it has such high density that even humans can float in it. But they need to make sure not to gulp its salty water. Let's perform a simple experiment to see what role density plays in floating and sinking of an object. Take 2 glasses filled with water. In the first glass, place a grape. In the second glass, add a few spoons of salt and then place a grape. You will notice that the grape sinks in the first glass while the grape floats in the second glass. In the first glass, the density of water is less than that of the grape, so it sinks. But in the second glass, the density of the water and salt solution is higher than that of grape, so it floats. Now, let us perform a simple activity to see what happens to the weight of a substance when immersed in the fluid. Take a piece of stone and tie it at the end of a spring balance with the help of a string. And note the reading in the spring balance. Then immerse the stone in a glass of water. And again take the reading in the spring balance. You will notice that there is a decrease in the reading, which means that there is a decrease in the weight of the stone. It is because there is an upward force acting on the stone. We know that this upward force is the buoyant force. But what is the magnitude of the buoyant force acting on any substance? The answer to this question was found by a Greek scientist named Archimedes. Archimedes found out the answer when he noticed that the water in a bathtub overflowed when he stepped into it. Archimedes shouted, "Eureka, Eureka!" meaning, "I have got it," as he ran through the streets. The Archimedes principle states that when a body is partially or fully immersed in the fluid, then an upward force acts on the body, which is equal to the weight of the fluid displaced by the body. Archimedes' principle is applied in various cases, like in designing ships and submarines, in lactometers to determine purity of milk, and in hydrometer to determine the density of liquids. We can find out if an object will sink or float in water by comparing its density with that of water. The ratio of the density of a substance to the density of water is known as its relative density. Relative density does not have a unit as it is the ratio of similar quantities. In this video, we learned about thrust and pressure.